What's up, everybody? So the word mold can be a little touchy. If it goes on a work order and the customer sees it, they could freak out. So I always try to avoid that word unless I'm 100% sure, or maybe we need to verify that it's actual mold, or you know what I mean? It's just be careful, okay, with the word mold. But anyway, we got Marlee Spiegelberg, and we also have Montana McElwain from Condair. Now, this all started when I watched a interview with Ben and Sophie from Condair at AHR talking about water activity factor. Is a new term that I've never heard of, and it correlates directly to RH. And there's a certain point in time where mold will start to produce, and it's correlated to RH and water activity factor. And this will be explained in this podcast. So it's a good one. You're going to learn some stuff, guys. This is the HVAC Know It All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. So the M word, Marlee, your name starts with M, and I was going to say it's one of those things. Anyway,
So does
mold.
Montana's, actually.
Yeah, so does Montana's. Look at that. I didn't even, put two together. So we're going to talk about mold, and we have two people whose name starts with M. So mold can kind of be a dirty word, and a lot of contractors don't like to write mold in a work order, because then it starts panic from the person who, if it's a home or if it's a commercial building, if you say, yeah, I found mold, then they start to panic. What kind of mold is it? Are we in jeopardy of any health risks, anything like that? So humidity is helps mold basically form, right? Because we need humidity, we need a humid area, and we need other things to happen as well for mold to get growing and stuff like that. And one of your colleagues, Sophia, was with one of my colleagues, Ben, down at AHR, and they had this discussion on mold and water activity. So Marlee, the word mold, is it as scary as it sounds, or can we maybe we'll lessen the fear on that word today if we can, potentially?
Yeah, no, I definitely think the word mold can be scary. I think mold can definitely be an issue, and it can lead to health risks, and it can lead to, like you said, people hesitate putting it on a work order because it means you have to do something about it, right?
Mm-hmm.
It can lead to like damage of a home or a business, and then there can be health repercussions. So they really do have to address it, and addressing it isn't always straightforward, right? There's a lot of work that goes into addressing a mold situation. But I think the problem is that we associate the word mold with moisture, right? So, and then we associate humidification with moisture as well, and then mold. And we've seen from the conversation with Sophia, and we've had other videos online as well. We talked about those residential systems as well, and how we actually had a video on that go viral, and a lot of the comments even talked about mold. So it's obviously at the forefront of people's minds when they look at humidification. But the science behind this is mold doesn't just grow anytime there's water. It needs access to both moisture and a food source. So it needs both of those in enough quantity for it to grow and really proliferate properly. So engineers that work with mold use this term called water activity factor to describe this phenomenon when it has enough of this food source and moisture source. So we can basically equate, I guess, relative humidity. So you have absolute moisture, right? So you have a space and you have an absolute amount of moisture absorbed in the air. And based on temperature, the air can hold so much moisture. So we can get a relative humidity by comparing the absolute amount of moisture in the space to how much moisture the air can actually hold. So that gives you your percent RH. So we can basically equate the relative humidity back to like this water activity reading. So if a building sits at 60% relative humidity and we let everything equal out, this will relate to water activity of about 0.6. So like directly proportional.
Okay.
Most organisms require water activity of more than 0.7 to proliferate.
7.
So that means a relative humidity about 70%, right? So to avoid moisture, we want to avoid prolonged exposures of buildings to relative humidity above 70%, or we want to keep it really below 80%. We know for human health, and for almost every process, we generally want the humidity, relative humidity between 40 to 60%, especially for human health applications. 40 to 60 is really the sweet spot. If we look at the Sterling chart, we look at all those, the health surveys and studies that have been done, 40 to 60 is the sweet spot. So you're not getting to that 70% or 0.7 water activity rate. We also want to minimize localized areas of high percent RH. So any time you get condensation forming, because that is about 100% relative humidity once you start to condense. So this means like air leaks, uninsulated cold pipes where you can get the humid air in the building, or 40 to 60% relative humidity air hitting these cold pipes and condensing on the surface, creating drips, creating water. And again, avoiding condensation within the building, especially when outside climate gets really cold as well. So the windows and outdoor.
Yeah, I was actually going to ask you about that when you were talking about it, because one of the things that came up, and I don't know if it was on that viral video about the mesh nebulizer. The mesh nebulizer, folks, for the audience, is like a localized humidification head where you serve it water and you can localize it to different rooms and stuff like that. That's just a generalized sort of description of it. But I think it was during that video, the comments, somebody said to me that they recommend a home only be at like 25-30% max humidity, because I guess in their experience, the windows start to condense because when it's cold outside. But I mean, that's probably because the window is failing and it's not a good window, right? So how do we balance the fact that we need 40 to 60% for the health factor of the human being, but we could have condensation, like you were saying, on the windows and stuff, because the condensation pooling at the bottom of a wooden window frame or something like that is not good either, right? So how do we balance that there?
Yeah, of course, like proper building, quality building materials is the first step. So getting those R factors in your insulation up across the whole building. Of course, windows are the worst part of the building in terms of insulation, where you're going to see the condensation. But we know that's not feasible for everybody, or cost feasible for everybody
Of
either.
course,
So
yeah.
one of the strategies that we really use in the winter, especially if we're based in Canada, so cold climate, right, is we'll do like a cold temperature step back. So we'll have a sensor on those cold areas like the windows or any piping or framework. And based on the outdoor conditions, we will bring back that relative humidity set point to avoid condensation on those materials. So 40 to 60, again, ideal for health. 40 is good, but in the winter, you can touch it back to 30 or 25% on those really cold days to get some of the benefits, but then not risk any condensation or any other moisture forming.
Okay. So I want to get Montana's take in this. He's just sitting there patiently ready to unleash his wisdom on us, right? With that amazing mustache of his. So let's Montana weigh in on this. Mold, water activity factor. I mean, trying to humidify the home versus trying to prevent condensation. The floor is yours, man.
I mean, by and large, I agree with everything Marlee has said. Kind of coming back to mold, you're going to see that more so in places that have long exposure to water. So places that have previously flooded, that might be a concern. Then, yeah, the water condensation, places where you have those cold places. So your windows, sometimes doors, your cold water pipes, anything where there might be a place for water to condense. A simple solution might also just be, for at least the cold water pipes, putting insulation on it. Otherwise, yeah, the sensor to maintain humidity at a lower range when we have, say, cold weather concerns is a big mitigating factor there. Otherwise, I can't really speak to the mold side too much. I'm predominantly on the adiabatic fogging, so I think this more comes up on residential. When you get into commercial spaces, the airflow throughout is huge, so you're not really going to see stagnant air there. Their concern is more, can we reach humidity, not is the air going to be too humid in this spot?
Yeah. Okay. So we'll get back to that in a bit for sure, because I want to talk about the commercial aspect too. So Marlee, I got a question for you. So that video that kind of went viral, and I wish I could remember the name of the account that it went viral on. I can't remember it right now. Maybe I'll look
The
it up.
smarter home.
Oh, it was Smarter Home. Okay, perfect.
Mhm.
Awesome. Thank you. Why was there so many comments in that feed about this system creating mold? Like what caused this? Is it just because they see mist in the air and they think the drywall is just going to absorb it and it's going to start to grow mold? Like what caused these comments of this? Like I didn't get it myself, because I know for a fact that if you control the moisture level in a building properly, you're not going to see this happen.
Yeah, that's a great question. When you first started phrasing it, I was thinking it's more the audience, to be honest. Like, it's because we're looking at the residential systems, we're looking at not HVAC experienced people, right? Like, for those, like you said yourself, who work in HVAC, yeah, you just have to control the environment. Like, we know too much about building IEQ control and air design in a building, but I I don't really, I'm not quite sure. I think it's just that correlation again between moisture leading to mold growth, and then if you're spraying water in an indoor environment, they think that you're going to have that condensation or moisture forming in areas. But in theory, if it's done properly, you shouldn't have any condensation. It should be fully evaporated into the air, right? Any moisture
If
that's
it's done properly, of
yeah,
course.
exactly.
Eh,
Yeah, if it's done properly. Yeah.
So I have experience with the commercial setting of spraying water into the air, and this is kind of I'll just give you a bit of a background on this particular space. It was a printing facility, and they had these big, huge Xerox machines in the facility. They had to be at a certain relative humidity. The machines, they'd spit back input from the surrounding air and tell you, yeah, the humidity's right, it's low, it's too high, whatever. So we would have humidifiers in there, just the basically steam humidifiers with a steam cylinder. It would boil off and it would rise out, and there would be a fan assembly at the top that would blow it into the room. And it's the same concept. It's mist in the air, and there was all kinds of paper in the room, all kinds of paper. So that's food for mold growth, really, if you have enough moisture. But we never saw mold in that room. Why? Because it was controlled properly with the right types of controls. Uh, that's a commercial application, Montana. Do you want to weigh in on something like that? I mean, a print room. I've also been in warehouses where uh, they made checks and they made magazines or whatever it was. It was a lot of paper, and they basically what they did was they had these little heads around the warehouse, and it was fed with water and it was fed with compressed air. And when the control said, "Hey, come on," it would open up a solenoid valve and feed water and air. And it would spray. You could like look up and there'd be like a fog in the air, but it once that came down and kind of moved around the building and equalized out, it was uniform, and there was never a chance of mold growth because it was controlled properly. So maybe that's where you're an expert in, is the commercial side. So speak to that if you don't mind.
Yeah. So I mean, in manufacturing and in industrial settings, you see a lot of humidifiers similar to that, where the processes are very dependent on the humidity in the space. So printing, you'll see issues with ink drying rates. Plastic, you'll see issues with the product that comes out being either too brittle or too soft. It's they care heavily about how much the relative humidity is. So controllability is kind of uh, a big factor there. A lot of the products we have have controls of like plus minus 2 or 4%. So we keep it very specifically within the range that the customer wants, because otherwise you'll see issues with not just say mold, but the product not coming out the way they need it to.
Mm-hmm. Now you used the word adiabatic earlier.
Correct.
Well, what is exactly does that mean?
That is cold water humidification. So you mentioned steam, that would be isothermal. Adiabatic is making small water particulate that evaporates in the space.
Okay, so the compressed air and water line feeding that head and spraying out, that would be considered adiabatic? Okay, cool. So so when did that sort of technology come around? Because most of what I've seen in the industry has been, and from my perspective, has been steam. Either a steam cylinder that's throwaway or a steam canister that's cleanable. It's mostly been that. So when did the cold water aspect come into this? And when and what is what and I guess that's part one. And what are the advantages of cold water versus steam? I guess I'll let you go to the floor on that one.
So with cold water, you are able to save a lot in energy. It's easier to pressurize water and shoot it out a nozzle and find particles and then have that evaporate, then heat up a vat of water to the point where it will steam and humidify a room. I can't really say as to when adiabatic has taken off. It's been in industry for decades, though it's been more popular, I think, within the last 5 to 10 years. It's more recently also been coming into healthcare, which is that's now very recent. But yeah, we're seeing more popularity in it in recent years.
Cool. So I'll come back to you, Marlee, because you said you have some information on the residential side regarding the mesh nebulizer. So that would be adiabatic, correct? And we agree on that,
Yes,
all of
correct.
us? Okay. So how do we, I mean, I've got a video that I put out with one of your colleagues, Todd Clark, again from AHR, and he was talking about just how sort of advanced these mesh nebulizer heads are that have this adiabatic approach or technology involved in them to prevent the over humidification of a space and prevent mold and your water activity factor of the building materials getting to 0.7. Can you
Yeah.
maybe talk about that a little bit?
Yeah, I can. Just to go back, so Montana's absolutely right. Adiabatic humidification has been around for a while. It kind of has a bad rep because it really started with the evaporative media technologies, and there wasn't a lot of technological advancements. There wasn't a lot of innovation or control, especially before we got these controllers with IoT and BMS and all the Internet of Things on those. So now with modern day controllers, we're able to have much more advanced adiabatic systems in terms of operation and hygiene, especially the hygiene features. Because you're not boiling the water, it's cold water. You have to be very aware of the water quality. So the water quality and the bacteria in the water. So most adiabatic systems need reverse osmosis or some type of water treatment because you're not boiling it to kill all the bacteria and viruses there. So again, there's been a lot of innovation in terms of hygienes now that we can have adiabatic systems in hospitals. So the MN, the mesh nebulizer product that we have has a lot of these new innovations built in that make it really a great product for humidity control in a residential application. So yes, the head is an adiabatic system again, so you're saving that energy, which is really nice because most homes generally would have a steam humidifier and it can add to your electrical bill, of course. So we have an adiabatic system for a home, which is kind of a new thing. And then on top of that, we have like IoT enablement. There's communication to each of these heads. There's a sensor in each head to sense the relative humidity in the space. And then you can have these heads work together in a space to reach your set point that you have, or they can work independently. And then again, they all have communication cables back to the main system, which has your main controller. So you can set each set point in the room separately using an app. It's just very user friendly and it allows for that really precise control. And then because you have has the piezoelectric transducer in the head, so that vibrating mesh, it can basically turn humidification on and off. So your accuracy is very high there.
Okay, cool. And people were talking about the maintenance of the head, but I was thinking about it after listening to Todd talk. You're going to have a localized area where you're going to filter the water, reverse osmosis, maybe even soften the water probably. And he mentioned something about UV treatment as well of the water. So really, if you think about it in theory, that head shouldn't really have to have any maintenance done because you're sending purified, clean water to it. The maintenance will be done where the filtration system is, maybe changing the filters or changing a UV light or adding salt to a water softener type thing. That's where the maintenance will be done. And that's not unlike any other water treatment. If you're going to do water treatment for your whole home, for your tap water, your drinking water, you're going to do these things anyway, right? So it's not something that's added to a procedure of treating water or a humidification head. It's already something that people have been doing, that have these treatment systems in place. Is that a fair statement?
Yeah, absolutely. And maintenance with a humidification system has always been kind of a hot topic, especially in both commercial and residential applications, actually. But you always have to clean a humidification system. So either there's two options. You either have to manually clean it out. So if you have a steam boiler, you have to, replace the cylinder, throw out a cylinder, or clean out a boiling tank. Or you use water treatment and then you reduce that manual labor of physically cleaning out scale buildup, and then you replace that with exactly what you said, replacing membranes, adding salt to a softener, adding active carbon to chlorinator. So for adiabatic systems, because the water quality is not just important for hygiene, but also for maintenance, we generally use some type of water treatment with those cold water systems. So you almost always have to use a reverse osmosis system for any cold water humidifier. And yeah, like you said, all the maintenance, you shouldn't have any maintenance on the nozzles. They would just need replacement after a certain period of time. And then all the maintenance is centralized again in that water treatment system.
Mm-hmm. Now, let me ask you this. Is there a residential application that is centralized, that has adiabatic technology? Like, for instance, maybe a head in a return duct that's adiabatic rather than steam. Is there something like that on the market, or do you guys have something like that at the moment?
So versus like the mesh nebulizer that's in each room, you're saying centralized, so you put
That's
in
a centralized. So it would be like a
they have
head in a duct, like a steam header in a duct, but
they call them bypass humidifiers, which are also very common. They often install them in homes too, like it comes with your furnace. Most people don't ever turn them on, to be honest, but it's an adiabatic humidifier and it has a media, and then your airflow passes over this wetted media and then adds humidification to the ductwork. But the thing with this for residential applications is your fan has to be running constantly in the home. So in the winter, when you want to humidify and your furnace is running, your heating, which is great because you want that heat energy in the air to pick up the moisture, your fan is going to have to run to humidify. So what's nice about the MN is it's separate from that ducted system, so it runs regardless if your fan is running. And then we see also a lot of these homes, new builds and high-end residential, they don't actually have ducted systems either. They do radiant heat.
So the bypass humidifier, like I've used them for years, and like when I was thinking this could be a product in the future, but you could feed cold water into a header, into a duct, and spray it in, and then that air would capture it and move it around the system. I think that would be a little bit more efficient than the the flow through the bypass type. I know a lot of people don't like the bypass type because they do require a bit of maintenance, and if you don't keep up on it and you don't have a water softener, you can get hard water deposits, and you go down to the thing a couple years later and it's just caked with hard water deposits all over it. And I've had to clean some of those, which is a pain in the butt. So my mind went directly to misting that cold water into a duct somehow.
I got you. So you would need water treatment if you're misting.
Yeah, for sure.
And you're spraying. So that's the kind of the advantage of the bypass, is you don't necessarily need it. But then you're saying, like you said, you're gonna be maintaining it. You're gonna be cleaning it out unless your water is good. But anytime you spray, because you're aerosolizing, you're going to have to use reverse osmosis water treatment. So if you use like an ultrasonic, you could do an ultrasonic spray. You could do high pressure for residential when it makes sense economically and just on the scale, like the air flows in the size of the ducts. But you could do like a small ultrasonic. But again, even ultrasonics, you reverse osmosis and deionized water. So you're getting an extra cost water wastage there as well because of the rejection rate of the RO system.
Gotcha. Okay, cool. All right. So Montana, I want to go back to this video that you made with Ben at AHR because you were showcasing some sort of product and it was cut to different sizes. Can you maybe talk about what that was?
Yes, this was wetted media, although at the time not wetted. It
And
was
what is that? What is that for? What is the purpose of it?
that is our evaporative media. So uh, airflow will pass through this wetted media and humidify the air that way. So similar to the induct, although we also use it in I believe it's pre-cooling towers. Yeah, the one in the showcase was the uh, fiberglass media. So that this has a flame rating, whereas most are made of some paper material. So burn quite readily. That
So
is
is this
more. Oh, sorry.
similar
Go ahead.
to a residential? I was going to say, is it similar to like a residential bypass type humidifier? Is this you're wetting the media in order to humidify a space?
Correct. It's that kind of media. But in AHR, we were looking at kind of the bigger applications of that. They will use those in much bigger ducts as well as pre-cooling towers.
Okay, so I've never seen that type of media that size used in a commercial application. So how would that work? Like, what would the setup be for that?
That very similar.
Is it?
Wetted media in a duct uh, with water either going over, going over it. Usually some level of sanitization and just air flow through it.
All right, so Montana, back to you. Healthcare. Healthcare, obviously, we want to have pristine indoor air quality in a healthcare environment for the patients and stuff like that. Can you maybe talk about what you guys are doing with adiabatic humidification in the healthcare sector?
Yes. So, healthcare, one of the biggest concerns is hygiene. There we push more so the DL. It's our most hygienic humidifier. One of the big factors there is the silver ion dosing that keeps the entire system very hygienic. It's received Fresenius certification, which is our a hygiene certification. It is the only humidifier that we have that has two humidification methods. So that is the spraying onto a ceramic media. So there's the misting and
Uh-huh.
evaporation off of that, and then the evaporative media is where air will pass through and water will evaporate off of that.
What's the purpose of the two types? Is it a fail safe, or is it just because we're gonna do it this way to be more efficient type thing?
Efficiency. So
Okay.
it's got a very small footprint in duct in comparison to most other humidifiers,
Hmm.
where some will take, I believe, up to 8 feet. We are in a footprint. So very easy to retrofit or design for in your air handler.
Okay. And we're talking about healthcare. Is this going into centralized systems for the entire hospital or medical facility, whatever it is, or are we targeting certain patient rooms with this?
This would be more for overall systems. I mean, it depended on how the AHU is designed, but yeah, we see this as kind of a central air design system predominantly.
Okay. All right. And how is that being controlled? If it's centralized, is it being controlled in duct, or do we have room sensors as well? Like, what's the control setup on that?
Each site is a little different. That's their design BMS system, but I believe a lot of them will use a room sensor with the air handler. So largely it's controlled in the air handler, but there might be a feedback from the room itself.
Yeah, that makes a lot of sense. I mean, we've done that too in my previous life when I did a little bit of building automation. It's always good to have more information. So in the room, and then at the air handler return supply, duct sensors as well. Cool. So I mean, great conversation, guys. So I learned a lot. I honestly, Marlee, when you started talking about the bypass type, I didn't realize that would be considered adiabatic because I had like mist in my head the whole time. But adiabatic is just any cold water humidification system. Period. Right?
Exactly. It's the principle of using the heat energy in the air to absorb the moisture versus an isothermal where you're adding heat to boil the water to produce steam.
Amazing. And water activity factor. I didn't even know what that was until I saw Sophia talk about that with Ben at AHR. I'm like, I've never even heard of that before. And I thought it was pretty cool that it's an easy correlation between RH and water activity factor, because it's basically 100% correlation between the two numbers, right?
Yeah, it definitely simplifies that way, and then it's easier to explain the science behind it. It's very niche, the water activity factor for mold, and then a lot of the food industry, they use that.
Amazing. Okay, guys. Well, thank you very much. I really appreciate this. And I look forward to doing a couple of more with these with your team at Condair, because indoor air quality, I guess there's been a real focus on indoor air quality since we had our blip in the radar, which was COVID back a few years ago. It really it focused on indoor air quality. Some people went way heavy on it. Some people didn't care about it. Some people did the right things. But I think a lot of it came from the top down. Like, I know around here, the dental industry, they had to prove so many air changes per hour in their space. And that was one of the big things. So a lot of different people were looking at indoor air quality differently. So thank you, guys. I appreciate it. We'll continue this on at a later date.
Thank you for having us.
Yeah, no
Yeah, of
problem.
course.